All right, we're moving into the middle part of chapter 4. And the middle part of chapter 4 is focusing entirely on factoring and how we take quadratic expressions and just expressions in general and we factor them. Now, the idea of factoring is basically the undoing of multiplying. So when we think about distributing and foiling, when we're multiplying expressions together, factoring is basically doing the reverse, going backwards and writing it as an expression of its factors. So you're kind of dividing things out and seeing what it would look like when it's made up of its product of factors. There are many different types of factoring. There are 4 that we're going to focus on in this particular chapter. 3 of them that are going to be in this section. So what I've decided to do is make a short video on each type, and then that way you get a chance to practice it when you go to Delta Math, that particular type. So this video is going to entirely focus on what's called GCF factoring, or greatest common factor. A GCF is the largest factor, the largest value that the terms have in common. You do this back in like kind of Dodge time when you're working with numbers and you're trying to find the biggest number that divides evenly into a group of numbers. That's called finding the GCF. Now, when we're working algebraically, the GCF can include numbers. So you could have everything divisible by 4, for example. It can include variables. So you could have everything that has an x in it. And it can even have exponents with those variables. So your GCF in algebra, compared to maybe when you did this in 4th, 5th, or 6th grade, has a variety of things that can be considered the GCF, or what I can take out that they all have in common. So we're going to start with really simple ones, and then we're going to kind of work our way up in difficulty, and Delta Math will do the same. It will have different levels depending on how big the GCF is or how big the expression is. So we're trying to figure out what all of the terms, whether like example A has 2 terms, so you're just looking at 2 terms, or example B has 3 terms. What is the largest number that we can divide out, and what is the largest value of the variables that we can divide out? Sometimes I call this the takeout method, because that's what you're figuring out. What can I take out? So if we look at letter A, 6 and 9, the greatest common factor between 6 and 9 is a 3. So we're going to take a 3 out. We also have both of the terms having an x in it. They both have a single x in it. I can't take out an x squared because the first term has an x squared. The second term only has a single x. So that is what you take out. That is your GCF. And then in parentheses, you put your leftovers. What are you left with when you divide out a 3x? So if I divide a 3x out of a 6x squared, I'm left with a 2x. You're essentially going to divide your coefficients, and you're going to subtract out your x's. I took 1x out. I'm left with 1. And then for 9x, when I divide 9x by 3x, I'm left with just a 3. What I like about factoring in general, and this idea of how do you check your answer, all you have to do to check your answer with these is just distribute it back. So you can see if you distribute, do you get the same thing as what you started with? I will admit I am totally a math nerd when it comes to factoring. It's one of my favorite things to do in algebra because I think it's quick and it's really easy to check your work. It's almost like you're filling out a puzzle. I do want to mention something with B. If your first term is negative, your GCF always has to include a negative. Always, always, always. If that very first term is negative, you have to include a negative sign as part of your common factor. Now I'm going to look at all my numbers, a 9, a 9, and 18. They all can be divided by 9. They don't have any common variable part because this term here doesn't have a variable. And so I cannot take something out if everything doesn't have it. So negative 9 is my GCF. When I divide everything by a negative 9, I'm left with a y squared, a plus y, and a plus 2. The next one, again, I don't have a variable that I can take out because I don't have an x in the last term. So I'm just looking numerically. The only number that they can all be divided by is 4. You always want the biggest number. So you might look and say, but they all can be divided by 2. You're right, but you want the greatest common factor, not just any common factor. So when I divide out a 4, I'm left with x squared plus 5x minus 56 divided by 4 is 14. Next one, 16 and 48, those can both be divided by 16. So your GCF is 16. You might have picked 2 or 4. There, you got to get bigger. And then they both have at least one x. So my GCF is 16x. I am left with an x, and I'm left with a minus 3. When I divide 48 by 16, I get a 3. And then when I take the x out, I don't have any x's left in the parentheses. We can get ones that are a little more complicated that have more variables. So you can have X's and Y's, you can have A's and B's. So this one, first I look at the numbers, 4 and 16, I can take a 4 out. Then I look at my A's. I have A to the second there and just A to the first here. So they both have at least a single A. And then I'm going to look at my B's. The first one has a single B. The second term has a B squared. So I can only take out a single B because that's what they both have. And then I want to look at each term and figure out what didn't I take out? What's left? So I took out the 4. I took out an A. I took out a B. The only thing left in the first term is an A. The second term, 16 divided by 4 is 4. I took out the A. I still have a B left over. So that's how you handle if you have multiple variables. Basically, just go one at a time. Look at each variable and see, do they have anything in common? The next example is something, it looks really weird, but it's actually a very simple way to factor. We call this chunking factoring, which doesn't sound super attractive. The idea is what they have in common is they both have this chunk. They both have an x minus 4. So that entire binomial, that entire chunk can come out front. The other thing that I have to worry about here is they both have we start with a negative sign. If my first term is negative, I also have to take out a negative. So I have two things that I can take out when I factor this one. I can take out a negative because the first term is negative, and I can take out the entire chunk of x minus 4. When I do that, what I'm left with is I'm left with the 2x, and I'm left with the 3. I don't have a negative anymore because I pulled that out, so I have a plus 3. That is called chunking factoring, or factoring out a binomial. This one's the same idea. They both have this chunk. They both have this x squared plus x. That's the only thing they have in common. So what I have left is I still have a 15xy, and I still have a minus ab. So that's how you take out a big piece or a big chunk. Here's one that has lots of terms, lots of variables, lots of numbers. So we're going to go one piece at a time. We've got 24, a 36, and a 12. The greatest common factor between 24, 36, and 12 is 12. Then we're going to look at the x's. We have an x to the second, an x to the fifth, and an x to the third. They all have at least two x's. They all have at least an x squared, so that's what's going to come out. Then I'm going to look at my y's. They all have, let's see, we have a y to the third, a y to the second, and a y to the fourth. They all have a y to the second. And then finally, I'm going to look at my z's. I'm just going to circle them. I have a z, a z. I don't have any z's on the last term. So that means I cannot take something out if one term doesn't have it. So my GCF is going to be 12x squared, y squared. And then I'm going to look in each term and see what's left. So my first term, I have a 2 left. All my x's are out. I have a y left, and I have a z left. Minus, when I take 36 divided by 12, I get 3. I have an x to the third left and a z left. And my last term, I took the 12 divided by 12. You can write a 1 if you want, or you can leave it. I still have an x left and a y to the second left. So I have lots of leftovers. I have a big GCF because I have just bigger terms, more values to look at. These are the last two I want to do with you, and I just want to kind of show you some special situations with this, and then you can go off and do delta math and practice. First one I want to show you is, what if nothing do they have in common? So if you look at this one, 17 and 6, there's no GCF for that. In fact, 17 is a prime number. And then when you look at your variables, the first term has an x, the second term has a y. Neither of them have anything in common. If that is the case, then we will just say that this is already simplified. There is no factoring that can be done because there is no GCF. It doesn't happen very often, but if it does, you don't have any work to do with it. Last one I want to show you, something a little different happens. So I have a 15, a 21, and a 3. The greatest number that can come out, the greatest common factor, is a 3. I have an x squared, and an x. So they all have at least a single x. And then I have a y squared, and a y. They all have at least a single y. So I'm going to write down what's left. I'm left with a 5 and an x for the first term. I'm left with a 7, an x, and a y for the second term. The last one, and this is why I want to finish with this one. If you take everything out, so if you look at this, you started with a 3xy, you took out a 3xy, we have to put a 1 there as a placeholder. Think about when you divide by itself, you always get 1. If you ignore that, if you just kind of end the parentheses, then if you try to distribute, you'll actually lose a term. So you never want to lose a term when I'm factoring. You want to make sure everything's accounted for. So if you take everything out, you will have a 1 there as a placeholder. So that is a quick rundown of GCF. You're now going to go to Delta Math and practice to make sure you're comfortable.